Hey guys, we are back for lesson 78. Number 1 says, 5 people can fit in each car. 79 people will go on the trip. How many cars are needed so that all the people can go on the trip? So there's a lot of information there. So we can get 5 people in each car. And there's 79 people that have to go in those cars, right? So 79 is getting divided up into groups of 5, right? And we have to figure out how many cars are needed. So if there's any extra people, we have to add one more car. We'll have to remember to do that at the end, okay? So the problem we're gonna set up, and they didn't give us enough workspace, so I'm gonna grab a scratch paper. And remember, if you want to do your work on in a notebook and just take a picture of it and hand it in, you can certainly do that because they're trying to fit lots of things on these pages now. So the problem we're going to set up is 79 divided by 5. So we're going to put 79 in groups of 5, and we're going to see how many groups we can make, right? And if we have any leftovers, we have to add on one more group because we can't leave any people home. We have to add one more car, okay? So 5 into 7 goes once. 1 times 5 is 5. Subtract. 7 take away 5 is 2. And now we bring down the next number, 9. Now we do a division problem all over again. So if you want to picture it, you don't have to write it like this every time, but if you want to picture it, you're dividing it 5 into this now. 5 into 29 goes 5 times. 5 times 5 is 25, and we subtract again. 9 take away 5 is 4. And we don't have any numbers to bring down, but we have a remainder of 4. So that means we have 15 cars that need to go, but we have 4 extra people, so there's actually 16 cars that we'll need to have, right? So our number sentence is going to look like this. 79, we divided it by 5. Our answer was 15 with a remainder of 4 people left over. So the answer in a normal division problem would be this, but they're asking about how many cars we need for all of the people. So we're actually going to need 16 cars because those 4 people need a car, okay? Next, at what temperature are the Fahrenheit and Celsius temperatures the same? So we're going to go over here. And we're going to look up and down this thermometer and try to see when the Fahrenheit temperatures on this side and the Celsius temperatures on this side match up. And I think I spotted it. So I was looking at the zeros, they're here. And as I go up, I don't see that any of these numbers are matching straight across. They're just getting further and further apart. But I do notice here, and I don't understand why this happens, -20, -20, -40, -40. I don't really understand why it happens that way, but it looks like -40 and -40 are both at the same line. So, see it? So at what temperature are the Fahrenheit and Celsius temperatures the same? 40 degrees, and I'm not going to label it Fahrenheit or Celsius. 72 degrees Fahrenheit is a comfortable room temperature. About what Celsius temperature is this equal to? So 72 Fahrenheit, about what Celsius temperature is it equal to? 72. So I see, this is our Fahrenheit side, I see 60 and I see 80. So right in the middle, that line is 70, and I'm gonna go up 1, looks like it's about there. So on the Celsius side, that's 20, and on the Celsius side, I'm also noticing we're counting by 10s over here, where we were counting by 2s over here, or I'm sorry, we're counting by 1s over here, where we were counting by 2s over here, because 20, there's 10 little marks between 20 and 30. So this is actually 22 degrees Celsius. If you come kind of close on that, just because I know you're working with a picture and not an actual sheet, I'm fine with that. Shade the thermometer to show negative 10 degrees Fahrenheit. So we're going to look at the Fahrenheit side, and we're going to negative 10. So here's 0, and halfway between the 0 and the negative 20 is negative 10. There's a line right there, and we're going to shade down from that line. Okay, Shanice made 3 by 5 array using the stamps she collects. So, and remember, an array is like lines of dots or lines of something like that. Draw and label the array. So an array actually represents multiplication, and that's why we have that multiplication sign. We can call it by, the way they did here, or we can call it multiplying. So 1, 2, 3 by 5. So we need to go 1, 2, 3, 4, 5 in each line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a 3 by 5 array. There's 3 lines down, there's 5 lines across. Amber bought a set of markers for $2.42. How much change did she get back from a $10 bill? Okay, I'm going to do this one on scratch paper too, because they don't give us much room. So she paid with $10. The most important part when you're subtracting with decimal points is aligning up the decimal points. You can never get a right answer if you don't have your decimal points lined up. And she bought something for $2.42. They want to know what the difference is, how much money she's going to get back. Okay? So, remember when we're borrowing, if the bigger number's on the bottom, we have to borrow. And we can't borrow from 0, so we have to go all the way to this neighbor. Borrow 1, make it a 0, give it to the neighbor. Borrow 1, make it a 9, give to the neighbor. Borrow 1, make it a 9, give to the neighbor. Now we're ready. 10 take away 2 is 8. 9 take away 4 is 5. 9 take away 2 is 7. And nothing else. $7.58. Okay, so this next one is our new skill for today. We're going to start talking fractions, mixed number fractions and improper fractions. So a mixed number fraction has a whole number plus a fraction, like 2.5. 2.5 cookies would be like 2 whole cookies and a half cookie, right? An improper fraction is when the number on the top of the fraction, the numerator, is bigger than the number on the bottom. So I'm going to show you about that. Write a mixed number and improper fraction to show where each arrow is pointing. So we have this number line, and we have to figure out real quick what it's separated into. So I see 1, 2, 3, 4 is separated into fourths, isn't it? Okay, so A is 1 and 1/4, right? A is 1 and 1/4. Now, in order to make it an improper fraction, there's what we do is we do the denominator times the whole number plus the numerator. This times this plus this. 4 times 1 is 4, plus 1 is 5, and then we just bring the denominator over. 5 over 4. The improper fraction is 5 over 4. They're not giving me enough room to write a number over another number, so I might write my fractions with a slash line, like the diagonal line instead of the horizontal line. Just so you know, you can write it either way. Okay, so mixed number for B. 2 and 1, 2, 3 fourths, 3 out of 4. Okay, so the mixed number is 2 and 3 out of 4. Now remember what we do. This times this plus this. 4 times 2 is 8, plus 3 is 11. And then we bring the denominator over. 11 fourths. Last one. Okay, C is 3 and 1, 2 fourths, 2 out of 4. And remember what we do, this times this plus this. 3 times 4 is 12, plus 2 is 14 fourths. So 3 and 2 fourths, 14 fourths. Okay, that was your new skill. Let's do our last calculations real quick. 73 times 26. So, let me see if I have a little post-it. It's written on, but you'll get the point. Okay, so 6 times 3, 18. 6 times 7 is 42, and one more is 43. Now, we take this off, move it over here. And we put a 0 down here to say that we're done with this guy. Okay? 2 times 3 is 6. 2 times 7 is 14. Add them up. 8 plus 0 is 8. 6 plus 3 is 9. 4 plus 4 is 8. And bring down the 1. Okay? And 1, 2, 3, comma. 1898. Okay. Let's do this. 3 into 93. 93 divided by 3. 3 goes into 9 3 times. 3 times 3 is 9. Subtract and bring down the next one. 3 goes into 3 one time, and it went in evenly. Very nice. You don't have to deal with remainders. Subtract again, and you get 0 and no more numbers to bring down. So 3 goes into 93 31 times. Let's do the next one. 4 into 57. 4 goes into 5 one time. 1 times 4 is 4. Subtract 1, bring down the 7. 4 goes into 17 4 times. 4 times 4 is 16. Now, get your multiplication chart out for this. If you don't have one handy, Google multiplication chart and use one for this if your multiplication facts are a little foggy. 7 take away 6 is 1, and we have no more numbers to bring down, so that means our remainder is 1. 14, remainder 1. 42. 5 does not go into 4. You can put a 0 there if you want to show that you tried it. And then we're going to move on. 5 into 42. Let's see. 5 times 8 is 40, so I would say it goes in 8 times. 8 times 5 is 40. Subtract, and we get 2, and there's nothing else to bring down, so it's 8, remainder 2. 8, remainder 2. Okay? Now, when you type these problems into a calculator, it's not going to tell you your answer with a remainder. It's going to give you a decimal point, and it's not going to look the same. So if you're checking your answer with a calculator, don't correct your answer to look like what the calculator says. If it's close, like if your whole number is right, just let it be. Because you probably have the right answer, but a calculator will not give you the exact same answer as you get when you're reporting remainders. So anyway, have a good afternoon, guys.